Welcome, my name is Mr. Clay and this is my third revision video for Chemistry Unit 6, Chemistry Out There, on the hydrogen-oxygen fuel cell. What I'm looking for you to get out of this video is how a hydrogen-oxygen fuel cell works, including the basic word equations and the symbol equations involved, explaining the changes that take place at the electrodes, including half equations, and to give the advantages and disadvantages of hydrogen fuel cells, including how it is associated with the production of pollution, despite not producing any waste products other than water itself. Okay, starting with the basics. Hydrogen is a very flammable gas. It explodes with oxygen very easily. It's an extremely exothermic reaction, and when it does so, water vapour is produced. Essentially what you're looking at is hydrogen plus oxygen gives you H2O. A little bit of balancing in there. So if we can harness the energy from that reaction in a useful way, we can use it to power many things and make sure that the waste product that we produce is relatively clean, doesn't have carbon dioxide associated with burning fossil fuels, for example. This is a hydrogen fuel cell. Hydrogen fuel in here, oxygen fuel in there, with the production of water. The first stage in this process is the hydrogen gas becomes ionized. So in order for that to happen, it has to lose its electrons. So the hydrogen comes in here and the electrons are lost. This leads to the production of two hydrogen ions. The electrons go off around the external circuit, and the hydrogen gas, the hydrogen ions, can diffuse through the proton exchange membrane. This is an example of an oxidation reaction. If you remember, in oxidation is the loss of electrons, reduction is gaining electrons. So because this hydrogen gas is losing electrons, it's becoming oxidized. So as I said, at that point, the protons that have been produced can then diffuse through the proton exchange membrane. Hydrogen gas cannot pass through here, neither can electrons, just the protons through the proton exchange membrane. The electrons are going around the external circuit, and that's the current that's flowing. When the protons arrive at the cathode, they react with the oxygen gas that's coming in and the electrons that have gone around the external circuit to form water vapour. The reaction is here. Hydrogen ions react with oxygen gas and 4 electrons needed to neutralise the 4 positive charges there to form 2 water molecules. This is the reduction reaction. The reason for this is because electrons are gained. As a side point, the reason why this reaction takes place at the cathode is because the cathode being negative, the hydrogen ions are attracted to the negative cathode because they are positive. So in this redox reaction, the reduction takes place at the cathode and the oxidation happens at the anode. Remember, in any redox reaction, a reduction and an oxidation take place. This is a way of showing what's going on in the reaction. This is an energy level diagram. In an energy level diagram, you represent how much energy is contained within the reactants and the products, and the difference between the height of the two lines indicates how much energy is either released or absorbed during the reaction. In this case, because the reactants contain more energy than the products, we have a net energy release, which means that this is an exothermic reaction and heat is given out to the surroundings. Moving on to the uses of hydrogen fuel cells. They are extremely lightweight and compact units, and they have no moving parts. This is really important because with no moving parts, there's less things to go wrong. Also, they only produce water as a byproduct. In space, this can be really useful because it can be used to provide drinking water for the astronauts. The car industry is also interested in the use of hydrogen fuel cells. This is because, as previously stated, they only produce water as the waste product, there's no carbon emissions, and there's a large source of hydrogen. i.e. seawater or any water can be used to produce it. This gets over some of the major barriers that the car industry is facing today, in that the fuels that they use, which are finite resources, only non-renewable, petrol and diesel, will run out and are becoming more and more expensive. And they also produce carbon dioxide, which is associated with the greenhouse effect and global warming. One of the major problems that has to be overcome, however, is the fact that cars get crashed, and cars containing hydrogen gas that get crashed could explode very, very violently. This is one of the main barriers that we've currently got in the development of hydrogen fuel cell cars. That and the fact that they don't have a great range, they can't travel a long distance between refueling. There is also a problem with infrastructure. The good thing about petrol stations is that they're everywhere. You don't have to go very far between from one to another if you're going to run out of fuel. However, hydrogen fuel cell fueling stations, well, I don't think I've ever seen one. So before this went in commercially, you'd have to make sure there was the infrastructure in place to support hydrogen fuel cell cars. An associated problem that you get with the use of hydrogen fuel cells that people don't really realise is that most of the world's hydrogen is actually produced from fossil fuels, from the reaction of steam with coal or natural gas. You can produce hydrogen through electrolysis, but that requires electricity. Most of the electricity in the world is generated from fossil fuels, so there is associated carbon dioxide produced from the production of hydrogen. The only way around this would be to make sure that the hydrogen gas was produced by electrolysis from sustainable electricity sources. Another major disadvantage is the catalysts, the proton exchange membrane that the hydrogen fuel cells are made out of. They are usually poisonous rare earth metals, and because of this they have to be disposed of safely at the end of their useful life and hopefully recycled to be used again. That concludes this video on hydrogen oxygen fuel cells. Hopefully you've seen now how useful they can be and how good they are for the environment in terms of the fuel that they use and the waste products that they produce. You've hopefully seen the other advantages in terms of the lack of moving parts and that type of thing, and the disadvantages associated with where the hydrogen comes from and the materials that they are made out of. I would hope you would also be able to explain how they worked, including the half equations for the process at the anode, where the hydrogen ions have electrons reduced, therefore are oxidized, and the process that takes place at the cathode, where the hydrogen and oxygen is oxidized, gaining electrons to form water molecules. My name is Mr. Clee. If you need any assistance, come and see me or any of your science teachers to help you.